Welcome. In this tutorial, suppose you take a free energy versus composition curve, and if you draw a tangent to this curve at any point, the intercepts on the pure A and pure B axis along the y axis basically give you the chemical potential. This is what we want to prove. So, to prove that, so again we are going to use the definition of chemical potential and some trigonometry to prove this. So, let us start with the definition of chemical potential. So, what is mu A? We define mu A as the free energy change for changing the number of A atoms, but by keeping everything else a constant. This G prime is there because G prime represents the total free energy of the system. Okay. Similarly, mu B is defined as how much does the free energy change when you change the number of B atoms by keeping all the other quantities a constant. In other words, you can write that the free energy of a given system is nothing but mu A dNA plus mu B dNB. Okay. Now, Na plus Nb, okay, so let us take this quantity Na plus Nb and let us divide this by Na plus Nb. So, this is dG prime, that is dNA dNb. So, this is the change in the free energy, total free energy. So, if I divide this by Na plus Nb is nothing but mu A dNA by Na plus Nb, and this is mu B dNb by Na plus Nb. So, why are we doing this? Because then you can define this quantity dNA by Na plus Nb as dxa. Okay. So, that is the reason why we are doing this. So, from this expression we have dG this is free energy per mole, because Na plus Nb I have defined. So, mu A dxa plus mu B dxb. So, this is what we have. Now, from this, suppose if I want to get dG by dxb, what is this quantity? This is mu A dxa by dxb plus mu B, but dxa should be equal to minus dxb, because see xa plus xb is equal to 1. Why? Because Na plus Nb, and so xa is Na by Na plus Nb, Xb is Nb by Na plus Nb. So, you put them together, you get this. So, dxa should be equal to minus dxb. In other words, you have this property dG by dxb should be equal to minus mu A plus mu B. Okay. So, this is one expression. Now, we can also write G to be equal to mu A xa plus mu B xb. Now, where does this come from? See, you can see this expression. Okay. Suppose if I change the number of atoms in the system, but I change them in the proper proportion. Okay. So, I change it by 1 mole, but that 1 mole is given by xa A atoms and xb B atoms. So, that is what makes it 1 mole. So, then you can see that if the dNA is to dNb is in the same ratio as xa is to xb, I would not have changed the composition of the system at all, but I would have changed the free energy, and because G is energy per mole, then you get this expression. So, from here it is clear that what is mu B? It is G minus mu A xa divided by xb. So, this is another expression. Now, dG by dxb is minus mu A plus mu B, and I can put this expression for mu B here. So, I get dG by dxb as follows. So, I get the expression dG by dxb. So, dG by dxb to be equal to minus mu A plus G minus mu A xa by xb. Okay. So, now let me take xb dG by dxb is nothing but minus mu A xb plus G minus mu A xa and so I can write this. So I can pull out minus mu a, then x a plus x b plus g, and so this is 1. So that means what? Mu a is nothing but g minus x b dg by dxb. Okay. So now let me consider a free energy versus composition diagram, and the diagram looks like this. Okay. So I have a free energy versus composition diagram. Okay. I have some point P. At that point P, I am going to draw a common tangent, a tangent to the curve, and let us say R is the point at which it happens, and let us draw a line parallel to x axis, and let us the curve that is joining P R cuts this horizontal line at Q, let us say. So let me call this point as S, this point as O, which is pure A point, and this is P, and this is T. So okay, so this is pure A, this is pure B. So I have this point O P T, then S Q U, and then S R V. Okay. Now we have defined the mu A as nothing but G minus x b dg by dxb, right. So now what is this quantity? Let us look at G. What is this? So P R is nothing but G, right, that is the free energy curve. So P R is G minus x b, dg by dxb is basically the slope. So that is nothing but R q by S q, right, R q by S q, but S q is nothing but A p, which is nothing but x b itself. So this is equal to x b. So this is going to go. So you are going to get P R minus R q. So P R minus R q is basically the intercept S, right, P R minus R q. So it is basically P q, which is nothing but O S. In other words, mu A geometrically is nothing but the tangent curve where it cuts the pure A axis. That is basically the, so it is extrapolation of the tangent at x b composition to the A line, right. In a similar fashion, you can also try to define mu b. From the earlier expression, we know that mu b is nothing but, okay, so let us take mu b. So what is mu b? Mu b is nothing but mu A plus dg by dxb. Okay, so this is one of the expressions that we derived earlier. So mu b is nothing but mu A plus dg by dxb. Mu A just now we proved is equal to OS plus dg by dxb. So this is the what is dg, and that is uv, okay, by dxb is nothing but us on the curve, but that is the entire distance on the curve. So that is equal to 1. So OS is equal to uv. So it is OS plus uv, that is nothing but TV, okay, on the curve. So in other words, mu b is nothing but extrapolation to the B line of the tangent, right. So this is OS plus uv is nothing but Tv, because Tu and Os are the same, because this is a horizontal line. So you get, so in other words what we have proved is that you can take the free energy versus composition curve, at any point you draw a tangent, wherever the tangent cuts the A axis, that is xb equal to 0 is basically the chemical potential for A, and wherever it cuts the other axis B, which is xb equal to 1, is basically the chemical potential for B. Okay. So this is what we wanted to prove in this tutorial, that you can take a free energy versus composition curve, at any point you can take a tangent and then extrapolate the tangent to the pure A and pure B line, and the intercept basically gives you the chemical potential for that composition in this system. Okay. So that is what we have proved, and that is what we wanted to prove. Thank you.